All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 73 is on the screen. Shouldn't take you long. By now, we should be experts at all these four, yes? Yes, Mr. Q. All right, good. Today, we're moving on because I want to finish this section on quadratic equations so that we can move on now to the more funner portion. Yes, funner, that's my word. Let's go. So, see how you do with that? Use some time. And then from there, get a Cornell milk going, please. All right, check with the neighbors, see where they're at so far, and then let's get this show on the road. All right. Good communication, man. How's your weekend, by the way? Pretty good? Yeah? Did we need an extra day or what? All right. Yeah, right? Yeah, that's okay. We're back and deal with it. Bah! Let's go. Right? Am I right? Am I right? It is what it is. Anthony D., what'd you get for 1? Complete the square. 1/2 squared, which is? Hands, if you got that? That is correct. Woo. And why 1/2, everyone? Because the coefficient right here on the second term is a 1 divided by 2 squared. All right. So what are your factors, Anthony D? Squared. Yeah, that is correct. Number 2, Mr. Q. Once again, this is square root of -1 times square root of 36, which is square root of -1 is I. Square root of 36 is 6, so 6I. All right, let's go to addition. Check with your neighbor, and Anthony's going to pass it to someone. Addition, what'd you get for addition? Addition. Pass someone, Anthony D. Addition. Bailey, what'd you get for addition? All right, help her out, Martin. Addition. What? Brandon, Darty. $13 plus 2I, that is correct. Double check your work. Hands, have you got that? Yep. Subtraction. What'd you get for subtraction? Pass someone? Brandon? Me? All right, I'll pass it back to Brandon. What'd you get? Brandon Darty? Subtraction? -17. Hands, have you got that? That is correct. How about multiplication? What'd you get for multiplication? Pass someone? Brandon? David, what'd you get for multiplication? I squared plus what? 15I minus 2I minus 30. Okay, however, remind your neighbor what to substitute in for I squared. Yes. What do we substitute for I squared, Noah? -1, that is correct. So I'm going to combine these two right here, 15 minus 2, that's 13I, bring down the -30, and then at the end, -1 and -30, that's -31, plus 13I. And have you got that? Some of you, all right. Division. For the sake of time, here goes. I minus 2 divided by I plus 15. It's in there once. I plus 15. Subtract. Minus and minus. So that leaves us with -17 as the remainder. So my answer is 1 plus -17 over I plus 15. All right, inverses. F inverse of X. Share with your neighbor, see what you got for the inverses, and then we'll have Rebecca give us for A inverses. Yeah, because it looks like Brandon Felix got it and Jaden has got it as well. Pretty good. All right. Rebecca, for A. 2x minus 5. Hands if you got that. That is correct. How about for B? Pass someone, Rebecca. Anthony E, what you get? All right. We'll give Anthony E some time to finish that one. And in the meantime, copy the agenda, please. Agenda for today, warm-up number 73, quadratic equations. Home play for tonight is a play sheet, 121, 122, numbers 3 to 13 only. It's going to be in the Nearpod presentation, so make sure you copy the code. Okay? Yes, Mr. Q. All right, good. Once you copy the agenda, get a Cornell note going. Today we're going a little bit, we're going to be moving along pretty stealth, or should I say expeditiously. Damn, that's a good word, right? Like, I'm telling you, I got this. Yeah. All right. So, get that Cornell note going, and then we're waiting on Anthony E to give us answer for B. We'll come back to that. Here's your code. Write this down. TZWGY. 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 That's your access to the home play, so make sure you copy that. Those of you that are following along on YouTube, make sure if you want to access the practice, it's in there. When you get to some slides that require answers, just scribble over them, and that moves you along till you get to the PDF page or sheet. Okay? Yes, Mr. Q. All right? So, I can solve and graph quadratic equations. We already did completing the square and quadratic formula. We had a pop party on Friday. We'll talk about retakes about that this week, and I'm still finishing up correcting those. So get a Cornell note going. You don't need a fair model today. And, oh, let me go back to the warm-up. My bad. Let's see. We had f of x equals 2/5 x minus 4, and the inverse is 5x plus 20 over 2. Hands, have you got that? That is correct. Let's go. Oh, yeah, we got this. All right, I'll give you guys some time to set. Are we ready? Jaden, we ready? Let's go. So, quadratic equations. Today we're moving on to applications, which is your favorite part, which is word problems. Let's go. Right? Oh, yeah, we got this. So, before we move on, though, remind your neighbor the definition of quadratic equations. They should know that by heart now. Definition of quadratic equations. Definition. You guys all right? Come on, it's Monday. Let's go. Let's go. My goodness. All right, let's see. Looks like Jaden's got it. Quadratic equations, Jaden. They are what? Very close. Very close. But what is quadratic? The highest degree is what? 2. That is correct. 2 variable equations, highest degree of 2. So we're still in the middle of that. We covered, we talked about the solving by graphing, square roots, and factoring, yes. We talked about completing the square. We did several of those. We talked about the quadratic formula. Remind your neighbor the quadratic formula without looking at your notes one more time, please. All right, Martin, go. X equals minus b plus minus square root squared, b squared, minus 4 AC over. Okay, not bad. Like those cars that go like, yeah, but we got there, all right. Yeah. So we got some of those. We did some of those in practice, yeah. All right. So it brings us to the next portion. This next portion I love because now we can actually use everything that we practiced and apply it. So I'm going to take you back in time. I think it was about a month ago when I reminded you that we were about to get here. And some of the formulas that we're going to see today, guys, have to do with gravity. So, example, here's my basketball. And I think I showed you guys. Did I show you guys? Yeah? What's that? Really? Oh, okay. So anyways, what keeps the ball spinning on my finger, aside from skills? Gravity, that is correct. Just like the Earth has a pull towards the center. That formula, guys, of the Earth pulling everything to the center is computed or approximated by 32 feet per second squared. They calculated something like that. How many feet per second squared? 32. Today, we're going to be talking about objects that fall, but from a certain distance, so at a standstill and starting to fall using the formula. So instead of doing 32, which is the pull of gravity, we're just looking at one direction. So I'm not going to get into the mathematics portion of it in regards to how we got to that formula, but the formula, instead of being 32, they divide by 2, and it's going to start with 16. 16 has to do with partially with gravity pull, okay? And so yeah, I got skills like that. How about quadratic? Distance of fallen in feet in t seconds. Do that in blue on the left side. D of t equals 16t squared. And on the right side is a second formula known as height in feet at the time t in seconds, where h of o is the initial height in feet. If you want to copy that in green, that definition, and here's the formula. H of t equals h of o minus 16t squared. Copy that. I'll give you some time. Go. All right, so here goes. Let me break down the first formula. Look up to the screen. So it says distance fallen. That means this pertains to what? Distance. Yes, that's distance. And then we have time in t seconds. And how many? Seconds. That means this t right here, if you want to do that in red, like that, you remember this is talking about what? Seconds. Time in seconds. Okay? So, question. Look up to the screen. Do you notice that there's only one distance in this formula? Yes, it's right there, Mr. Q, distance of t. All right. Let's go to the second one. The second one, look at it. Instead of distance, now it has h of t, which means height. But it's still a distance, isn't it? So therefore, that one also underlined in blue. H of t. There it is. Height in feet. It's still a distance. We know that t in seconds, it's still what? Time in seconds. That t is in red. But what do you guys notice now? That we have a what? A second height. Here's a second height in green. Or h of o, which is known as what? The initial height. Initial height. So look at these two formulas. Notice that this one has how many distances? 2. How many distances does the first one have? 1. The second one has what? 2 distances. The first one has what? 1 distance. Second one has how many? 2. The first one has 1. Okay. Are we there so far? Okay. So with that said, check this out. Look at this first problem, and it reads, writing utensils down, look up to the screen. It reads, write and solve an equation to answer the question. Give the exact answer, and if it's irrational or decimal approximation to the nearest tenth of a second. It says, if you drop a water balloon, how long does it take to fall 4 feet. So think about it. If you drop a water balloon, how long does it take to drop 4 feet? Question, how many distances are we going to be figuring out? How many distances? We're right here. 1 distance, is that correct? Therefore, which formula am I going to use? Tell your neighbor, which formula am I going to use? The distance from d of t equals 16t squared. So on your paper, write example 3. Write the problem. If you drop the water balloon, how long does it take to fall 4 feet? Write the formula. And then I'm going to help you illustrate this. Here it goes, example 3. For those of us that are artistically challenged, here we go. I'm gonna help you out. Here it goes. Check out my skills right here. Pretty good, yeah? Be nice. Oh, sorry, forgot some muscles here. There it is. My hocus, here it goes. Woo-wee, hocus, go. Hocus. There it is. All right, so here's my, man, this arm is kind of short. By the way, I have long arms, believe it or not. Like, let's see, how tall are you, Dan? Let's see, about you, Brendan. How tall? 6. I'm 5'11", and I can probably outreach Brandon. Why? Because I have long arms, believe it or not. All right, so here's my hand right here, and my 2 fingers holding a balloon. All right, copy that, please. Yeah, I'm helping you guys out. I don't want you guys to stress out. There you go. Is that okay? All right. Now, I got better skills than that, believe it or not, but I don't want to overwhelm you guys and be like, Mr. Q, can I have your autograph? No. I look like if I'm upset or something, right? All right. But check out the hair, right? We got that? Let's go. Yeah. All right. So, let's check out the problem again. If you drop a water balloon, how long does it take to fall 4 feet? So from here to here, how tall is that, guys? Label that 4 feet. And that is this is our distance, or d of t, distance. All right. So with that said, we get our formula. What are we going to substitute in here for distance, everyone? That is correct. So 4 equals 16t squared. All right. So to solve these kind of problems, what do we do, Mr. Q? Well, we need, it's a quadratic equation. We need it equal to what? 0. Or, check this out, we need to leave t by itself by using what method? Square roots, is that correct? So to leave t squared by itself, because we need to solve for t. What do I need to do here, guys, to get rid of that 16? Divide by 16, divide by 16. That leaves us with t squared equals to 4 over 16. And lastly, how do we get rid of that squared? Square root, that is correct. That's why it's called square root method. Square root, this cancels that. So t stands for seconds. How long does it take the balloon to fall? What is square root of 4, everyone? 2. What is square root of 16? 4. And this is plus minus, right? But think about it. If T stands for time, talk to your neighbor in regards to these two signs that we wrote here. What would you say to your neighbor? If T stands for time, what about these two signs? What about those two signs? Then we'll have Brandon Felix enlighten us. What about those two signs if T stands for seconds? So what about these two signs if we are to talk about T that stands for seconds? Brandon Felix. Yes, what about these two signs? Yeah, we cannot use the negative, so we cancel this one, so we only use the what? Positive, because we're not Superman to go back in time, right? There's no negative time. So, can we simplify this fraction? Yes, 1/2 equals T. So what does that mean? Let's read the problem. If you drop a water balloon, how long does it take to fall 4 feet? Answer, let's write our sentence. The water balloon will drop 4 feet in approximately what? Approximately half a second. That is correct. 10 feet. Pretty straightforward, yes? From 1 to 5, I'll come to borrow you with this. Okay, once again, why did we use this distance formula? Because here it only talked about one distance of the falling balloon, only one distance. Okay? So, with that said, copy this next one, example 3Q, and it reads, the rooftop of a 5-story building is 50 feet above ground. How long does it take the water balloon drop from the rooftop to pass by the 3rd-story window in 24 feet? So do me a favor, instead of copying all the verbiage, just copy the diagram, please. Copy the diagram. I'll give you guys some time for that. Go. Also on your diagram, guys, over here on this end, I want you to draw a little balloon, like so. Balloon. Point to it. Some of you that are artistically challenged, it looks like a bean or a peanut or something. All right, so let's label this. It reads, the rooftop of a 5-story building is 50 feet from the ground. So this is already labeled 50 feet. So what do we call that? A distance, is that correct? But it's also a height. So this is a height, so let's label this H. Okay. And then it says, how long does it take the water balloon drop from the rooftop, once it drops, to pass by the 3rd-story window that is 24 feet? Isn't this another distance? Isn't it another height? Yeah, so label this one also H. Question to you, which is the original height? The 50, so we're going to label this one H of O. Which means this one is just our what? H of what? T, that is correct. So, look at your formulas, tell your neighbor which formula are we going to use now for this one. All right, very good. All right, read me the formula. Danny, go. H of T equals H of O minus 16T squared. Okay. So, to keep us organized, here we go. I'm going to label this one in green, this one in blue. So, this one in blue. this one in green. And of course, the red is our time. Is that correct? So time t squared. All right? So, what do we substitute here, guys, for h of t? 24. Okay, so 24 for h of t. But now, about h of o, everyone? 50 minus 16t squared. All right, so now we have a more robust equation, but I think we can still solve for t by using square roots, yes? So to leave t by itself, what do we do to that 50, everyone? Subtract 50, subtract 50. That leaves us with negative 26 equals negative 16t squared. Tell your neighbor what to do next to leave t squared by itself. What do we do next at that point? What do we do next? What do we do next? Brandon, Felix, pass someone. Danny, what do I do next? Divide by negative 16 to both sides. That is correct. That leaves us with 26 over 16 equals t squared. What would be our last step, everyone? Square root. That is correct. Square root, square root. So t is approximately, let's see, can we take the square root of 16? Yes, that's 4. Can we take the square root of 26? Not really. Plus, minus. But are we going to use the minus, guys? No, we don't use the minus because we're talking about time. However, what does square root of 26 divided by 4 mean? We don't know unless we make what? The 26. Square root of 26. Yeah, decimal. Here we go. So on the side, I want you to write square root of 26. Let's see. Who remembers how to get the decimal for this one? Looks like Bree's got it. Very good, Bree. Let's go. Courtney Jean. Danelli's got it. Let's go. David. All right. So here it goes again for those that forgot. Between what two perfect square numbers is 26 found? Between 25 and what? 36. That is correct. Let me move this up for those of you in the back. Here it goes. So, 26 is in between 25 and 36. Do you agree with that? Yes? So therefore, this is going to be approximately, square root of 25 is 5 point something. So how do we find that something? Well, you take the middle number, subtract from the smallest. That is 1. Divided by, you take the large number from the small and subtract. What is 36 minus 25? That's 11. So, let's find our decimal for this. 11 divides into 1. It doesn't fit. Add a 0. Doesn't fit. Add another 0. So if it's in there 9 times, that's 99. I'll stop right there. So this is 5.09. So now that we know what square root of 26 is, I'm going to substitute that in here. 5.09 divided by 4 is approximately how much time? So you do the division. I'll give you guys some time. 5.09 divided by 4. How many seconds is that? Don't say it out loud. Do the computation, please. If you have calculators, that's fine, I guess. Looks like Jaden's got it. Very good, Jaden. All right. Jazzy's got it. Let's go, Jazzy. Got this. All right. Let's see. Emily P., go. approximately, what is our time? 475. 1.475, that's a positive second, which is close to what, guys? 1.475 is close to what? Close to what? 1.5? So let's round it to 1.5, just so that we have that idea in our noodle. So, what would be our statement at the end? Here goes the problem again. It reads, how long does it take a water balloon drop from the rooftop to pass by the third-story window at 24 feet? So we would write what? The balloon will pass the third-story window at 24 feet in approximately 1.5 seconds. 10Q. Ooh-wee. Notice now we're using all the skills that we've been working on the warm-ups and quadratic equations and such, but now applying them to word problems, okay? So, how are we doing so far? Good? From 1 to 5, how comfortable are you with these two formulas? That's the 3s, 4s, 5s, 5, 4s, okay? So, just to recap, here it goes again. Notice the difference in the diagrams. Look at this diagram and look at the previous example. The face. How many heights do we have here labeled? 1, that's why we use this formula. Look at the second one. How many heights did we have labeled here? 2, that's why we use this formula with 2 heights. That's the difference from one to the other. Now, you're going to encounter some problems that might look like this. Look up. Don't copy this one. Where they actually give us the formula. Do you guys see the distance formula right here? They give us the formula, and all we have to substitute in here is the distance. What was the distance for the tool to fall? 4 feet, so we would just substitute that in there and do the same process we did on the previous. Okay? So, that's on distance. So now let's talk about areas. Copy this one, please. Example 3 Shazam cube. 3 Shazam cube. I know some of you are like, oh, these are my favorite, Mr. Cube. Takes me back to geometry. Let's go. So, copy the rectangle. The base is 3x, the height is 2x, and the problem reads, the area of the rectangle is 60 centimeters squared. 60 centimeters squared. Example 3 Shazam cube. I'll give you some time to set that up. Go. All right, so for tonight's home plate, you're going to have an example, one problem that, like the first example, a problem like the second example, and a problem like this example. So let's talk this one over. It says, the area of a rectangle. Remind your neighbor, what would be the formula for the area of a rectangle? What would be the formula to find the area of a rectangle? Fifth grade stuff, guys. Think about it. Area of a rectangle is... Let's see. How about Jacob A? Area of a rectangle. How do we find that? Area equals. Listen. Length times width. That is correct. But I like to use area equals base times height. How about them apples? Either one works. Okay. So, with that said, the base here is this one. I'm going to label that in red. The height is in green. And do we have an area? Do they give us an area? Yes, right here, and I'm going to do that in blue. So now that we have all the information, here it goes. What do I substitute for A, everyone? 60, that is correct. Equals, for the base, that's 3x. For multiplication, I'm going to put these in parentheses instead of writing the little dot. Well, I'll write the dot here. Multiplication. Times, what is the height? Height is 2x. All right, so let's simplify this. Here we go. 60 equals, what is 3x times 2x? 6 what? 6x squared. That is correct. All right, that should look familiar as to what we've been doing with the other ones, right? What would be my next step? Tell your neighbor, please, what would be my next step? Then Anthony is going to enlighten us. What would be my next step? Next step. Anthony, D, next step. Divide by 6, because we need to leave x squared by itself. That leaves us with 10 equals to x squared. Next step, Rylan, go. Square root. This cancels this. And then we got approximately x equals plus minus square root of 10. Okay. What is square root of 10? If we're talking about distance, we want to know, because here they're talking about what? Centimeters, right? Do we know what this is? No, unless we find the decimal equivalent. By the way, look up. This is what? Exact. Yes? But do we want exact? No. That means x equals, when they ask for it exact, just leave it in square root form. But they're going to ask you for this approximately. So, between what two perfect square numbers is 10 found? Bree. 4 and, well, actually, there's one closer. 9, okay. So between 9 and 16, that is correct. So this one is approximately, what is square root of 9? That's 3 point something. All right, let's find that something. Subtract these, that's 1. Divided by, subtract these, that is 7. So, 1 divided by 7 does not fit in there, add a 0. Fits in there once. 3, add another 0. Fits in there 4 times, 28. 2 left over, that's okay. And we'll leave it at 3.14. Okay. So, exactly x equals, and by the way, we can't use negative because distances are not negative distances, right? It's only all positive. So, x is approximately, and this is equal, exact, approximately what? 3.14 what? Centimeters. All right, so let's write our base. What does the base measure? 3 times, let's first write it exactly, square root of 10. So this is 3 square root of 10 centimeters. And this is what? Exact. Which means if we find approximately, so approximately, we would write what? 3 times 3.14, which is very good, 9.42 centimeters. Woo-wee. Jaden from the corner, let's go. And this is approximately. So this is the base. Find me the measurement of the height, exact and approximate. I just helped you out with the base. So what is the height? Exact and approximate. Exact and approximate. Find me that value, please. Go. All right, Kimberly, what'd you get for the exact? 2 times what? What is it? Oh. Square root of 10 centimeters. That is correct. That is exact. That's the height. Therefore, what is the approximate? Pass someone, Kimberly, approximate. Trinity, what'd you get? 6.28 centimeters, approximately. And you put the wiggle so that it indicates that it's approximate. That is correct. That's exactly how the home plate is going to ask you to represent it. Exact or approximate. Okay? From 1 to 5, how comfortable are you with these area models? 5 4s, 5 4s. Okay. We're almost done. We got about 7 minutes left, so copy this one. Example number 4. Right, example 4. We're moving on from word problems now to imaginary. Here we go. Copy this one. Example 4, write 5i. 5i. There's going to be a section in tonight's home plate where they ask you to square each imaginary number. So what are they going to ask us to do? Square. So what do? Put this in parentheses, squared. So here we go. What is 5 squared? 25. What is I squared? I squared. And of course, after that we do what, everyone? Substitute what? -1. Bring down to 25. So what is 25 times -1? -25. Let's go. Oh, yeah. This is too easy, right? Here goes another one. Crank it up a bit. Copy this one. Example 4 cubed. Reeling you guys in like little by little. And we're going to do what? Again, square it, yes? So, what is -I times -I? Let me write it out. -I. Oh my goodness. Wow. -I times -I, then square root of 2 times square root of 2. All right, here it goes. -I times -I is I squared. Is that correct? Because negative times a negative is a positive. Times square root of 2 times square root of 2 is square root of 4, because 2 times 2 is 4. Okay. So what is square root of 4? 2. What is I squared? -1. So therefore, -2. How are we doing? Once again, guys, some of you that are going to make it big in life, come back and hook me up some technology that works really well, please. We'll stop right there, yeah? All right? All right, so make sure you do your home plate. You will have the code for the Nearpop presentation. If you need extra support, so you know what happens after school here. Yeah, there's tutoring, and it's free. Ah, my goodness. Stop right there.